I'm also going to go live.
All right, we are now live on Aether Cosmology. If you are tuning in live or not live, thank you for being here. And we're just casually chatting at the moment, but we are going to be discussing Robert Bennett's presentation to Alan and Witsit last week regarding, it was basically his second presentation regarding the Æther. So we're going to go through that, and Alan's going to comment, and we're going to all comment. And yeah, thanks for being here.
Well, we're all going to comment, all three of us, then. Or were more people showing up?
Oh, I'm assuming so, but I hear my laptop behind me playing the live stream, so I'm going to have to stop that really quick.
Nice. I knew it. I was just thinking, dude, Clearview will be here.
Yeah, I went and used the bathroom, and then I saw, I was like, oh, reminder.
Yeah, I saw a bunch of people that usually hang out in Flat. Man, I haven't been over there, so I feel bad poaching. Well, I feel a little bad.
I was already interested.
Yo, what up, boys? You're live on YouTube as well. All right, Toby, did you do your intro?
Yep.
All right,
Yep,
cool.
yep.
Let me screen share this to show Shane real quick. So Shane, you know how you were saying like, do more visual stuff in the presentations or whatever kind of thing?
Yep.
So
You went
check
crazy
it out.
with AI. Nice.
Dude, I may or may not have went
Nice.
crazy with it. So check it out. I added some background stuff.
That's what PowerPoint is supposed to be, my dog.
Dude, is that not the sickest?
That looks good.
I don't know. I kind of like the one from last Monday better.
Really? Where it's just blank? Where it's just fucking blank text?
It's just blank. It still had like empty text boxes and stuff everywhere that said add text here.
It's supposed to be like minimal visuals while you just rail them with your words, right? That's what PowerPoint's supposed to be.
I mean, I'm gonna try. I'm giving it a try. So my second rendition will hopefully be a lot better, and then I'm gonna go more in depth on the J.J. Thompson thing because I didn't realize how significant all this was gonna be. So this was a cool treasure trove of stuff to go over. So that'll be the preview for Thursday, so everyone can tune in to that with slightly more visuals now and bigger text font, so everything's readable.
Be over at Geo's, you mean?
Yeah, this looks great, dude.
It'll be live on Geo's. So
I love that thumbnail. That thumbnail's the coolest.
Yeah, it's nuts. So very cool. All right, so let's get into Bennett here.
So was the second half much more technical than the first, or
dude,
did it go largely the same?
It was just as good as the first half, if not better, because there was just so many like quick, concise breakdowns, that just really sealed it. Like he goes over covariance in like 3 minutes and just get like, once you hear it, you're like, oh yeah, so that's the rules. Okay, so all this stuff has to be in alignment with like actual, like there's rules, you know what I mean? Because it's not just abstract math. And then like once you understand the violations of the rules and all that, you can really kind of piece it together, in my opinion. But yeah, there was so many like really good clips. So yeah, we're gonna go over those. Let me share the.
I've seen a couple of clips that Toby made of Witsit, rattling off and summarizing some really important, complex issues really succinctly. So those are pretty awesome.
Nice. All right, here we go. So I got some timestamps here. Let me. Ooh, that was bad to pull that up on stream. All right, let me make sure. Took a real gamble there, opening up that window. That's funny. All right. Just had phone numbers on it. Nothing too crazy. Let's see. Where are my notes at? I swear I came prepared.
Might have got too high, Your Honor.
No. Okay, here we go. Summary of the Wang work. All right, here we go. So he gives a quick summary of Wang, and then he gets into Newton's bucket, which is crazy. I don't know. Have you guys ever heard of the Newton's bucket thing?
No. I don't think so.
Yeah. Yeah, this is all crazy. So, playback speed faster. just a little bit faster. And turn off the subtitles. All right.
Results were basically, now the position we're measuring in.
Nice.
All right, I want to cover this because this was the last slide and I kind of rushed through it. If you recall, the Wang test was an answer to the criticism of Sagnac that it was done and tested a rotational ether. Wang used a conveyor to cause the ether to be dragged in a linear line, and the results were posted right down here in the corner in the graph. The results were basically that the test showed that in the lab and on the conveyor, the speed of light is c plus v. Now this is kinematics, meaning it's a measurement, not a prediction from a law of physics. Now special relativity gets destroyed by this because special relativity specifies that the speed of light is always c. So postulate 2 of special relativity is a dead item. In order to continue with the discussion of the model, consider what happened.
Rest in peace. I mean, the dude called it science propaganda analysis and obituary for a reason. He came for bodies, dude. So
I don't know how do we know that space isn't relativistically drifting in one direction everywhere all at the same time?
Because it's a preferred direction. What do you mean?
I know they would try to use some kind of crazy quantum geometry to explain it or something, but
I'm like, because there literally is no explanation.
No,
it's a
like pretty tough one to explain.
Rotational method. Like
even the theoretics of that one are not very easy to explain. I can't say
it's because it's spinning. I have no idea what the fuck the answer is. Right? Like there is no explanation.
If we have the conveyor and the lab tested according to the laws of physics. According to the laws of physics, if the ether is moving past the conveyor, then the speed of light should be c plus v, and it is measured as c plus v in the lab. Sorry.
In the lab, like in reality, not in like fantasy program.
Not in a mathematical coordinate system that bends and contorts based on things that aren't even in the same dimension.
Mathematical fantasy framework, which I can do anything.
Mm-hmm.
Okay. If you notice, the conveyor is predicted to have a speed of c, but it actually has c plus v. My interpretation of this is that you're measuring in a non-lab frame. The lab result is correct, c plus v. The conveyor reads c. So there's two conclusions that I draw from the Wang test. Number one, the speed of light is not c, it's c plus v. Number two, it is only correctly measured when you're in the lab frame. And we'll see that this is confirmed by Newton's bucket and other experiments that we will look at in part 2.
That is a proper conclusion to draw. Absolutely.
Dude, so when they get into things like the speed of with the speed of light, they're like, no, you have to do it has to be relativistic. That's when you can't use v plus c anymore. Like they explicitly make the distinction there, and it's like, well, why not? We measure it in the lab frame. Like, why would you not? Like, they literally got everyone to accept these equations and stuff. Like, this is how it all broke down, man. They just got everyone to accept that as their default. Like, they're measuring. Think about this. They're measuring c plus v in the lab frame, and they're like, all right, relativity confirmed. That's definitely c.
Calling it c all the time. Listen, it's always c, no matter what. Except when we measure it in the lab and in reality. But in all other cases, it's definitely just C. Like, no, isn't it like relative? No. It's always, nothing can go faster. It's always C. Dude, it's so funny. It's like, actually, the one time where we do measure it, it's always been C plus V. Oh. You don't say.
Now, I was introduced about 10 years ago to a book which recorded the visions. Now look at the science of Hildegard, the Æther. We saw that with the number disputes to the. It says
right, so here we go to the
correct
bucket situation.
He found that it didn't work at 3 laws of Newton. Now, when Newton wrote the Principia in 1687, he presented, of course, the 3 laws of Newton. He also discussed something which was an exception. He found out when he spun a bucket full of water and tried to apply his 3 laws, actually the second law, F equals ma, that it didn't work in certain situations. This is known as the Newton bucket experiment. So we start with stationary water in the lab frame. And remember, Newton is looking at this because he's standing stationary on Earth, and that's the lab frame. What you see after the water starts spinning with the bucket is a depression in the water in the center. You get a vortex, a whirlpool formed. And you can predict that that is going to happen by using Newton's law for centrifugal acceleration, mv²/r. The rotating water is subject to this law. It predicts that there will be a centripetal force, and so the law agrees with the result. We predict that the water will be thrown up the sides by the centrifugal force, and that's exactly what we see. Now let's pretend that there's a person on the bucket. Call it a bucketeer. This guy can make measurements from his point of view. To him, the bucket is not rotating. He's at rest. And he sees Newton and the lab rotating around him. So as Newton sees the bucket rotating clockwise, this guy sees Newton rotating counterclockwise. And we know that the result is going to be the same. If you're on the bucket, you have to see the same thing. You have to see a vortex formed, a whirlpool. But if you apply Newton's law to the guy on the bucket, to him the water is stationary because the water is rotating with the bucket. So the speed of the water measured from the bucket frame is 0. So the guy on the bucket would predict that the water surface is flat, but it's not. So Newton's law does not work on the bucket. It does work in the lab frame. There have been a lot of things through history, a lot of attempts to correct this. Mach's principle, which was stated almost 200 years after Newton talked about this, that principle is quoted incorrectly by mainstream. I give you 2 examples there. Physical law relating motion of distant stars to local inertial frame. So Mach is saying in that sentence that it's the distant stars that are rotating that somehow influence the water in the bucket. This is called an inertial influence. In another place in mainstream, I quoted local laws are determined by the large-scale structure of the universe. Well, that means everything in the universe, including the Earth, contributes to the effect that we see, the rotation of the bucket in the Earth frame causing a vortex. Now, what I did was I looked at the sources. I looked at the book that Mach wrote. And what it says is such forces are produced by the relative rotation with respect to the Earth and the other celestial objects. So what Mach actually said is it's the rotation with respect to the Earth and the other celestial objects, which is not what is quoted in the mainstream textbooks.
Well, look at that.
So Mach did say,
Dude, look at that.
Dude. Newton's bucket leads us right to the crux of the matter. Go figure.
Dude, it all comes back to a guy in his bucket. And we're all told about the apple that fell on his head. How about the bucket that the dude swung around?
Dude, I always wondered, what story were they hiding with the bullshit about an apple falling on the head? It was the bucket story that they were hiding.
Dude, the bucket story, man. The bucket story.
I mean, that's a really straightforward, logical body bag.
Right?
I'm not understanding it. Is it that the water, the guy, he thinks he's staying still, but he's going to look at the water and the water is essentially going to go up the edges of the bucket. So essentially there has to be a difference between the moving and non-moving frame, no matter what reference you're from.
It's all comes back to the speed being like C plus V. He's trying to do relativistic frames, right? We were talking about the resting frame and from wait, what the fuck?
I mean, I think that sounded about right. I think you're.
Yeah.
So you said like all the frames have to be equivalent, but in one frame he's standing still, yet the water has to essentially make a hump on the edges, which isn't possible from a still frame, right? If you're not moving, there should be.
Yeah, the example of Newton's bucket led us into this true derivation of Mach's principle, which he said was directly misquoted because the actual quote is the motion is derived from the spin of, not from the Earth, but from the spin of the other stars, meaning the ether. Literally it quotes the ether spin, the ether wind that we talk about, the toroidal vortex motion that we all measure. That's what Mach's principle was directly quoting, and then has been perverted in mainstream to mean like completely the other thing. That's what he's pointing out, which is awesome.
Yeah, so real quick, back on the bucket prediction, the guy in the bucket, mathematically makes the prediction, but it's the wrong it doesn't matter because we know that the bucket curves. So he can do the math equation and get 0 so that there's no water curve because he's at rest, but we know that that's not real. We know that that's not true. The frame's like invalidated by the fact that he's not actually at rest, and we can observe that the water curves when it's due to that motion.
Right. So he's kind of trying to compare
So
that, like,
if the Earth was spinning, there would be a curve. There would be like a difference. There would be a difference between reference frames, essentially, given this bucket scenario. But they say that there's not.
Yes, they try and tell us that we can't tell the difference between Earth rotation and Earth not rotating. This is the difference.
right. So
This is why the Earth isn't rotating.
This
is why
Are on the same, dude. That's crazy.
He's trying to say, like, kinematically they're equivalent, dude, right? Like, kinematically you can say either or and it makes a difference, but dynamically it's always one way or the other, meaning it's always the Earth-centered frame, like always, Earth-centered, everything rotating around. That's why it matters.
Yep. And then to get into the Mach's principal quote, which was been bastardized, as Shane, eloquently put it, the source of the rotation is coming from the stars, right? It's not coming from how do they say it? What do they even say now? They just say that it comes from nothing, right? No, they say that it comes from the stars too. How do they misquote it again? Because I've never heard it.
Scale structure of the universe is what he said.
So
it's determined by the law, which means it comes from everything. And he's like, that's not right. That's a perversion of the actual law. And the first way was the motion of the distant stars. So no, that's the right interpretation.
So I think you had it backwards.
Yeah, hold on.
A lot of
because it says mainstream there. Yeah.
Correct this. Mach's principle, which was stated almost 200 years after Newton talked about this, that principle is quoted incorrectly by mainstream. I give you two examples there. Physical law relating motion of distant stars to local inertial frame. So Mach is saying in that sentence that it's the distant stars that are rotating that somehow influence the water in the bucket.
Yeah, that sounds
This
retarded.
is called an
like
inertial
right.
influence. In another place in mainstream, I quoted local laws are determined by the large-scale structure of the universe. Well, that means everything in the universe, including the Earth, contributes to the effect that we see, the rotation of the bucket in the Earth frame causing a vortex. Now, what I did was I looked at the sources. I looked at the book that Mach wrote. And what it says is such forces are produced by the relative rotation with respect to the Earth and the other celestial objects.
Right.
So what Mach actually said is it's the rotation with respect to the Earth and the other celestial objects, which is not what is quoted in the mainstream textbooks.
So he says that the other celestial objects are caught up in that ether wind as we see them from Earth, not that they're the cause of it, right? Like, that would be weird.
Yep. Yeah, man. Pretty crazy.
So, I mean, like, I think an example of something that would be like a dynamic effect of a rotating Earth would be, as between like the argument between Kepler and Galileo, like basically you should be able to go up to a high tower and drop something, and then it shouldn't land right at the exact same point below where, because the velocity should change, because when you're higher up, you're further from the center, so you should have a measurable different velocity at the top than at the bottom of the tower. So the rock should actually land in front of the tower with respect to the rotation. So just like as trying to illustrate like the bucket effect, how we would see that on a rotating sphere, that's something that we should be able to experience, is the difference in velocity as the altitude changes.
You would think there would be something, like literally something, but there's just not. And then even if when there's not, they'll say, "Oh well, it's moving in lockstep," therefore blah blah blah, conservation, blah blah blah. Like there's always something,
So wait,
to make the ball appear stationary.
What was the problem with Newton's bucket? Wasn't that like they want to like make them equivalent, so they equivocate and they go kinematically, look, we can describe them the same, and they go, nuh-uh. Dynamically, when we're doing this, we can only have it one way, and they go, okay, we're gonna solve this. But they never solved it, and they've just been using that rule in heliocentrism ever since. Is that kind of what happened?
Yep.
Okay.
Yeah, because the mathematic framework that he came up with, like, I guess when Newton came up with, like, using this algebraic expression to kinematically express the celestial movements and stuff, right? Like that blew everyone away, dog. Everyone was like, "No way! Like this is the craziest shit ever!" Like they, so like they weren't trying to give that up, you know.
Yep. It makes sense now.
And it was all downhill from there. And they were like, yeah, but we can explain it in this frame, and like let's just not tell anyone.
It's why Galileo got kicked out of school, because he wanted to believe in this nonsense.
Well, there's some occult historicity to that, probably. Which perpetuated which narrative and who was trying to drive which point home, for sure.
Yeah. Oh, here's a good summation of the Newton's bucket. Here's a great way to another way to look at it. Here we go.
That reference frame exists, but he didn't say where it was. Now, I tried to update this experiment by doing something that's more familiar. Newton's bucket, the experiment is named after him, so I'm going to call this Bennett's hiker. We have, first of all, a hitchhiker frame, which is the same as the lab frame. If you have a car accelerating towards you as a hiker, and you ask, what do the laws of physics predict? Then the prediction is the force on the driver, Fd, is equal to the mass of the driver times the acceleration. So Newton's law says the driver should have a force exerted on it. And we all know this is true. If you're accelerating in a car, you can feel the car seat pressing on your back. And you could measure it with the appropriate equipment. So if you are in the hitchhiker frame, which is the lab frame, Newton's law is correct. Suppose you use the reference frame of the driver. In the driver's frame, you see the hitchhiker accelerating towards you with minus a acceleration. And you want the force on the hiker to be equal to the mass of the hiker times his acceleration. All right, the calculation shows that this is not zero. But we know that when a car passes you and it's accelerating, you don't feel any force. You may feel a slight breeze from the air that's moving past the car. But unlike the driver, anyone stationed in the lab frame will not feel any force. This is exactly the same as Newton found, that only in the lab frame, stationary on Earth, can the laws of physics be properly applied. Kinematics is an important concept. It means...
Yeah, we're told a lot of things about Newton, but we're not told that, right?
That's a pretty good one. Whoops.
Yep. Yeah, man. So here's going to get into some kinematics. So again, some good rhetoric on the kinematics and dynamics and the differences between them. So this is good here.
Measurement. Kinematics means measurement. Kinematics means measurement. Kinematics means measurement. I said it 3 times because if you've heard something 3 times, supposedly that's supposed to be part of your permanent memory. How did kinematics arise? Probably the astronomers noted the motion of the stars, and they began to track it and to make up charts which would predict in the future where the stars would appear in the sky. So these circles became associated with...
right? They tracked the motion of the stars to predict the motion of the stars. They didn't track the motion of the Earth to predict the motion of the stars.
Very logical way of doing it, I'd say.
Right?
Measurements. And from that, we could interpret mathematical relationships. The acceleration of the stars must equal their speed squared over r. That's a consequence of the measurement. Galileo made measurements of a falling object, and he found that the speed of an object is proportional to the time, no matter what the weight of the object was. So he can generate from that a algebraic equation, a mathematical description of free fall. But all this is based on measurement. They're not applying any laws except using the measurements to generate the laws. So this is a process of induction. The law of the pendulum, same thing.
That,
you observe the pendulum swing, measure its period,
that Witsitgetsit uses
and
all
knowing
the
the
time.
length and the acceleration of gravity.
What's that? Kinematic derivation?
Yeah, that kinematic derivation of G over there on his right hand and that little graph I can barely see on my tiny screen. That's what
Yeah.
that's the same meme that Witsit uses all the time when he whips that out.
Oh, yeah.
Well, it's
Good one.
a different depiction of the same equation.
You can calculate the period. So the law is generated from measurements. Now, an important concept here is relative motion is valid. In kinematics, if I were 5 feet north of you, then you would have to be 5 feet south of me. That's an example of relative position. Repeat that with velocities, accelerations, and so on. And you'll find that measurements always obey relativity. So relativity is true for measurements.
So again, in kinematics, measurements, repeated 3 times, so it's all in our permanent memory. The relative motion it's cool. It's great. Right? So Einstein's whole entire framework of relativity, as long as it's not applied to anything real, it's good to go, right? So here's where we're going to get into the distinctions.
Or we could say observer reference frame independence. Kinematics is arguing from specific to general, and it measures the quantity of motion. And that's why mathematics is applied, because all you get from a measurement is a number. and you have to use that number to predict things in the future. Now, dynamics is the other branch of physics. If you were to study physics, you would probably choose either experimental physics, testing, or you would choose theoretical physics, which is a prediction of future motion. The prediction of motion involves quantities that we discussed before, distance, velocity, time. In addition, you have quantities that are characteristic of whatever you're measuring. So mass, force, moment of inertia, charge, Q, all of these things are particular qualities of motion. In kinematics, you only trace the path or the trajectory of motion. In dynamics, you must include mass and force and other qualities.
I'm so glad that he's going into this now that I happened to call it out earlier, and he's going into explaining exactly what it means. That's perfect.
Yeah.
Relative motion is invalid, and we're going to show that. We've already shown it with Newton's bucket and with the hitchhiker experiment. The observer and reference frame dependence means that we have a lab or earth frame as an absolute frame. And we've used, as I said, the bucket and the hiker. And we will use an electromagnetic experiment, the Faraday experiment, to show that only the lab frame can be used in making predictions. So dynamics is always prediction, and kinematics is always measurement.
Predictions and measurements. Measurements and predictions.
It's like, hey, actually, the lab frame is the only thing that matters for measurements, predictions, real life, companies where money's involved. Anytime we do anything that's real, it keeps coming back to it and keeps saying it. Actually, the lab frame is the only one we can use. Like, no kidding. So all these predictions for heliocentricity with all these other motions, that's all just what, like theory? And when it comes down to everything that works, say GPS and everything that is a measurement, everything for the military, then you actually go back to the dynamics and, Earth center, Earth friction, lab frame, resting frame. That's it.
Well, dude, think about this. They had to make Einstein's theory backwards compatible with Newton's stuff because it started off with like the lab frame dynamics, right? Like inertial rest frame.
Yeah.
And like rest mass and all that, like something at rest. It's like it had very clear definitions for all these things. And so when Einstein came in and was like, hey, mass and energy are the same, everyone was like, say what? Like, it was a whole big thing because it was ruining this dynamic relationship of rest mass. So it was like, well, what the hell is mass then? Like
that's a very good point, right? Holy crap.
Dude, watch the E equals MC squared on Thursday. It's insane. Like this is what
any of that. Yeah, I'm so glad I'm gonna watch your presentation.
Dude, this is what it all stemmed from the E equals MC squared. So you know how he did the pseudo tensor thing to satisfy the conservation laws and stuff. So all that was because he changed the definition of rest mass to make it equivalent to energy, and then everyone was like, okay, so like now what do we do? How do thou satisfy the conservation laws? Yep. So he had to use that special tensor that doesn't really do anything and all that stuff. Yeah. So it's all related. It all has to do with lab frame. Yep.
All has to be lab frame. Einstein figured out the mathematical way to get it out of there. So now every frame can be the same. Now we can move it and we can do coordinate system transforms and put all sorts of theoretical motion as long as we don't have to use dynamics for the lab frame. Then we can just keep on pretending and mathematically assimilating any new fucking measurement that we have to retroactively fit the fucking spherical nonsense. Holy crap.
Yeah.
Dude,
yeah, they never find their way back home.
Well, we just did.
Yeah.
You just got to go backwards.
I mean, we did.
We did. Figure out what they did.
Yep. That was a really concise rundown of how it works. So pretty cool stuff. So yeah, he ruined that backwards compatibility, and then he was trying to mathematically fix it for like the rest of his life, and he couldn't do it. He tried like 6 different times in different publications where he was like, this time I got it, boys, and it wasn't it. And then in his original 1905 paper, he didn't even mathematically show how he derived E equals MC squared. Your boy just inserted it into the expansion pack. He didn't even put in patch notes, bro. He just showed up and changed it unilaterally, and
you should rename it to like the philosophical and theoretical ramifications of E equals MC squared. Like unraveling that bad boy to see the historicity of the evolution of science, how it was, diverted, controlled thereafter. Man.
Yep, to maintain. Yeah.
This is awesome. All right, let's have him go for the rest of dynamics.
Absolutely.
Now, in the lower left, we see an example of how we're going to apply the laws of motion, how we're going to derive them. If you were a hiker hiking through the mountains and you wanted to go from A to B, there are many different paths you could use. You could use the red path, which goes over the mountain. You could use this one, which goes through a tunnel in the mountain, or you could use the blue path from A to B. In fact, there's an infinite number of ways you could get from A to B. And let's say we want to know, what is the fastest time that gets me from A to B? So this question was posed to mathematicians hundreds of years ago. And they came up with this law called the law of calculus, or variational principle. What it says is, if I take a quantity which represents the energy, the Lagrangian L, and that consists of the kinetic minus the potential energy, and it depends on the location, Q stands for some coordinate system, the velocities, and the time, so we need a clock. If we consider all of the paths that go from A to B in this example, and we ask what is the shortest time between them, then this variational principle is set to 0, and when it is calculated and simplified, it leads to what are called the Euler-Lagrange equations, which are these. So by performing these derivatives and applying it to the Lagrangian T minus V, you get the equation that predicts what is the shortest time between A and B. And this is quite an astounding accomplishment. It says that something I couldn't possibly do physically is done mathematically. We can predict what is the shortest path between 2 points if we know the energy change in between the 2 points. Now, the thing that they made a mistake on, this was done by mathematicians. They used generalized coordinates. They assumed you could use any coordinate system that you want. It turns out, however, from experiments, Newton's bucket, for example, that you must use the lab frame. So the mistake that is made by mainstream is in using arbitrary coordinates, arbitrary reference system. You must use the Earth system.
So to be clear, you can't make a measurement on Earth and then explain it with a reference system transformation to a different hypothetical position to explain why it's different in the reference frame that you measured it in to retroactively fit why you think it or how you're going to explain it as not being changed, but through a frame that you can't possibly verify physically.
It's so funny. It's so funny. Like, oh, they just assumed that in reality they could use any coordinate system because mathematically they kinematically make equivalent coordinate systems for nonsense transformations all the time, even though it's not supposed to. Like, oh yeah, well that's how reality works. And it turns out, nope. Actually, in reality, you have to go back to the lab frame, meaning Earth-centered, Earth-fixed, centered frame. Like you have to go, Earth's not moving, everything's moving around it, or nothing works. Wow.
Yeah. Funny how that works or doesn't work for the relativist,
Funny how it keeps not working for them that way, like over and over and over again.
That consistent not work.
Okay, this is something I borrowed from Austin's presentation.
Nice.
The only thing I want to point out is right here where Fred Hoyle says, it is also possible to take any point as the center, even in dynamics. No, not true. As I just described, you must use the lab frame as your reference point, as your center of calculation.
So to be clear there, you cannot take the hypothetical center of a rotating mass as the as your distinction point. It has to actually be a stationary place. Otherwise, your predictions are going to lead to nonsense, as in the bucket frame situation, where the calculation checks out, but it doesn't match the observation. So that's the difference there, old Fred Hoyle.
Yeah, are we gonna watch the part where he talks about the ESI frame that they use?
Oh, we certainly are.
Okay, good.
We certainly are, dude. I gotta get Shane caught up on that because that's crazy.
I mean, so yeah, it's
covariance.
Yeah, go ahead. Never mind. We'll get to it.
Okay.
I was about
All right, so we're gonna. Yeah, you're good. You're good. We're gonna get into covariance now and the relationship between these two frameworks and ways of analyzing problems, right? So the kinematics and dynamics, their usefulness, and the mathematical relationship between them.
This was a subject that I was asked to cover. What is covariance? It's a question about how do reference frames affect physical laws? Does the motion of the observer, in other words, affect whether your physical laws are correct or not? Mathematically, we could say if I have an equation which involves motion variables, and I ask if I change the coordinate system, like from Cartesian to polar, is the equation still the same form? Does a coordinate system change, like Cartesian to polar? If it doesn't change, then we have weak covariance, because all you're doing is changing the mathematical structure. If you change the reference system, though, not the coordinate system, if you have an observer on Earth and one on a satellite, and you ask, what are the changes in laws from if I go from Earth to satellite? If those equations are the same form, then you have strong covariance. For example, if F equals ma is true on Earth, is it true on the satellite? Where F prime equals ma prime are the measurements made on the satellite. So that's covariance. This is an important factor in physics because there are two types of reference frames. There's the Galilean frame, where anything that's moving at a speed v obeys this formula. According to Einstein, in order to keep the speed of light constant, you must use Lorentz transformations, which are shown in this red box. In this chart, we're going to compare Newton and Maxwell laws according to whether we have no ether, or we consider the mainstream, which is Einstein's covariance. All right, if we ask, are Newton's laws covariant? Well, they obey Galilean's law, and the answer is yes. Maxwell's laws, though, the laws of electromagnetism, do not obey Galileo's law. They obey the Lorentz law if you require that the speed of light is constant. In other words, if special relativity is true.
So if you need to contract your coordinate system to make the speed of light what you assume it to be, you hit them with a little Lorentzian.
Dude, it's like,
So when
the speed of light is constant everywhere, except for the places where it's not. And such places use this Lorentz transform to make it so it is again. That's exactly what he just said. Like what?
Oh, dude, I got a great tweet
Literally
we'll pull
magic.
up from an actual CERN physicist that makes some comments about he's like, yeah, you just, it's a result of a Lorentz transformation, but like not realizing what he's saying. And like, so we're gonna actually, let me pull that up so we don't.
Dude, like when you said it, like matter of fact, like that was just an answer, and I laughed. I felt like I shouldn't have been the only one. Like that's an absurd thing to say. Well, yeah, well it is. You just got to use this, handy dandy, always applicable universal transformation equation so that everything can contract back to reality, and we can mathematically retract it to the same reference frame, and we can project our actual Earth-centered lab frame up to this heliocentric coordinate system transform. Hey, what?
Yeah, you just hit him with a little transformation equation, dog. And if you just assume that those postulates are true, so if you assume that the speed of light is the same in all reference frames and all that, then you're good to go. You just apply then your justification for applying the what's it called? What do you call it? The your justification for applying the transformation in the first place.
Lorentz transformation.
Like you just wouldn't think anything of it.
It's it's a philosophical decision.
But like just to have to make the statement, like you just think like you're in this camp and you believe this. Like the speed of light is constant in all situations, except for the situations where it's not constant, and you just gotta quickly apply this transformation so that it's constant again. Like you have to believe that. Like that's your mathematical framework and that's your reality. Like what?
Yeah. I can't find the tweet, but yeah, I saw it earlier. It was literally the way he argued it was well, yeah, it's a result of the transformation. It's like, oh, buddy. So it's just a result of the mathematics that you imposed on it to explain what you think you're explaining in the moment, but you're not realizing that you're devaluing it in other regards because you're just admitting that it's not real. So you can't use it as a physical explanation for what's it called? I don't know, Michelson-Morley, all that kind of stuff.
Really, so, anytime you have to like Lorentz transform, you're admitting your thing isn't real, though. Like every single time.
Well, you're taking a leap of faith, right? You're like pledging. You're like, you're essentially, how do you even? You're just like you're worshiping your God to an extent, right?
Like the Lorentz transformation is back from actually we didn't measure it, but we did measure it, but it contracted exactly the amount as if we didn't measure it, and we'll never be able to know because the measure device we used to measure it contracted the same way. That's the transformation, right? The totally reasonable, rational transformation that we're applying to see in all the situations where it isn't constant. What?
Yeah. Yeah, and I would say that there are some situations probably where the Lorentz transformation makes the accurate prediction mathematically, but if you're going to use it, I would say that you're completely disregarding whatever the mechanism for whatever it is you're trying to figure out is. right?
Yeah.
Like you're just because like now at that point you're just applying an abstract contraction to
Real
to
things
make
for no reason. Yeah. Like
yeah
what?
to make the projection fit in certain circumstances. Like for example,
Yep.
when they did the Einsteinian clock synchronization, there's only one experiment where they got it to work for 14 hours at a maximum. That's like and then in practical use they don't even use Einsteinian synchronization. So it's like yeah, you can do some stuff occasionally with it, that like will make sense or whatever. But the story behind it, the mechanism involved, like time slowing down and link fit and the molecular structure,
Yeah, that's all
lattices
lore.
compressing,
Yeah.
like that's all mythology that
Yeah.
Lore.
doesn't have any value towards towards what you actually just witnessed and how you're explaining it. So
Sounds like an episode of Loki.
Yeah. Except, yeah. That's like pretty good lore.
of light is constant. In other words, its special relativity is true. So when in the 1900s, when they knew that there was a conflict between mechanics and electromagnetism, they had a choice. Do I make Lorentz Galilean or do I make Galileo Lorentz? But what they chose, the mainstream choice was, we'll make Newton's laws obey Lorentz transformations. And what that means is the gamma factor, which is the square root in the denominator, which contains the v squared over c squared, that's going to be forced into the equations, even though it does not appear in the Galilean equations. So
You got very upset there.
So by forcing Lorentz to be used for both mechanics and electromagnetism, the consequence of that was that the v squared over c squared became part of what is experimentally measured because it's part of the equations, but it is not part of the equations when it's Galilean. All right, so the correct prediction of covariance will be making mechanics and electromagnetism both invariant under Galilean transformations.
That's interesting too.
Okay, we're going to look at electromagnetic induction and look.
Yep. And before we get to that, so again with this covariance situation here, you know how they say that Einstein's equations or his field equations are backwards compatible with Newton's gravitational, all that stuff. That covariant relationship is how they hinge everything on, because remember Einstein changed the definition of rest mass, and then it would only be backwards compatible if you could satisfy those conservation laws, etc. Right? So that whole stress tensor thing, like this is going to become extremely important in my argumentation moving forward, because it's a death blow once you see the big picture of what happened and what they covered up, because there's like the whole history of the pseudo tensor and stress tensor and stuff is kind of like lost to history. They don't really talk about that anymore, and this is just the mathematics, because it works out. These kinematic equations are just assumed, they're taken at face value. And then people that I've talked to that are in academics now don't even know really about covariance. Like they're not like they're in a belief system that's validated by covariance, but they don't know how to they don't know about it. It's like,
but if you look at it and you see how it got stripped off, and then you see why it got stripped off, and then you see the direct repercussions for it being stripped off, you're like, oh yeah, oh shit, of course. Like we're describing it now, and I'm like, yeah, of course they did. Of course, no one recognizes the importance of the dynamics now. Of course, it's all kinematic sense. Of course, they've just been mathematically deriving the things back and forth, transforming them back and forth ever since, and dazzling everyone with mathematical garb, right? Like that quote from Newton that says, "It believes in Einstein." Like Einstein is just for a beggar wrapped in purple, convincing people of nonsense or something.
Oh, Tesla, yeah. I think that was a Tesla quote.
Yeah, I think that he was describing
allegedly.
I think he was describing relativity.
Yeah, something like that.
Yep. Yeah, that's what we were saying last week as well. Is of course, it's like it all already, just intuitively.
Yep.
And then you see it all, and it's like, oh, yep.
Yeah, dude, you try and tell them like, hey, did you guys check this stuff? They're like, yeah, it's all on the up and up. You're dumb if you don't understand it. It's your fault. And it's like you go through the historicity of it. It's like, hey, did you guys know that he never satisfied the conservation laws ever? And your theory doesn't. It's not even mathematically derived, like equals mc squared from the theory itself. So like, what's up with that? And they're just like, what muons?
They're like, yeah, what happened? How come you guys don't use covariance anymore? How come you totally dropped it off? How come you don't understand the ramifications of E equals
dude.
mc squared? If it's all the same and nothing matters, and you can mathematically derive things backward, and then relativistic effects can be contracted at whatever will to incorporate whatever measurement doesn't fit backwards into the model, then like what the fuck?
Yep, and that's where someone like Crothers came in and took the mathematical derivation for gravitational waves and transformed it to a coordinate system where the magnetic where the electric permittivity and the magnetic permeability aren't set to free space, and the propagation speed changes. So it's not a gravitational wave isn't even in an invariant transformation, so it has no covariance allegiance to the mythology at all. It's just something they present to the public to and then like that's it. Like it's a giant scam. It's not real. It has no physical meaning at all. It's derived from nonsense.
Gravity wave. Nice. So it's not like they took some electromagnetic wave and repurposed it out. They just invented it and made it up. I mean, that's kind of what they did with the publication of it, right? They put up this facility. They built it. We're going to detect gravity waves in some way, and then they like faked it. Like, look, everyone, we detected a gravity wave. Look, oh, actually, just kidding. Actually, that was a fake. It was a test. It was a test, and then later they were like, oh, we totally found one, and that was it, right? And then that was the gravity wave detection.
They built they built 1 million. Fuck. They spent $2 billion on 2 separate LIGO institutions, right? The most expensive orthogonal interferometers ever set up, right? They can't detect Earth's orbital velocity at all. Not even a whiff of it, as you said, Shane. They can't even smell it, dude. Like even as the Earth is rotating and it perfectly aligns and you get that nice linear velocity and you can apply Galilean velocity addition, not even then, bro, do they get it. But from an event that happened 11 million or 11 billion years ago, I can't remember which one, but it doesn't matter. From an event that happened then, according to mathematical derivations, right? There's a ripple through nothing.
That is some deep lore.
That's causing a change in the speed of light. That's equivalent to being the width of a proton. So they're measuring a fluctuation that's the speed of a proton. And now that we know that there's a daily sidereal fluctuation where the minimum and maximum dimensions are reached and all that, in correspondence to sidereal time, like we know that there's a fluctuation. So they're just completely zeroing that out. And then they're like, but we're measuring something that's the width of a proton. Guys, they dude, like they got us, boys. Like, well played, you know. Let's realize what's up.
Because, dude, like, who's gonna prove that I didn't detect the gravity wave? Who's gonna show me that I didn't detect a Shane particle? I'm the only one with a Shane particle detector, bitch.
Oh, ripple through nothing really got me.
Dude, the ripple through nothing, bro. A fabric of nothing, right? The fabric of the coordinate system used to abstractly describe motion in the sky. There's a ripple in there.
And then transform the motion and the actual carried out wave hypothetically to the transformed coordinate system for this ripple thing. They go, look, it's a gravity wave. Behold.
A science fiction writer couldn't do a better job.
Right?
It's beautiful.
Dude, a science fiction writer wrote it, dude. I think.
Yeah, he has a pretty good quote about Einstein being like a sky prophet. He just like did some math and said some stuff, and then people revere him. Like the mathematical creation of a black hole came from the mathematical nonsense from Einstein. So literally, he's creating like sky monsters from his like prophet status of mathematical nonsense.
Yeah, dude, did you know you could reverse engineer the size of a black hole to fit any phenomenon that doesn't explain your model because you can't actually define the size and dimensions of it or like what it even is. So you can just arbitrarily say, "Oh, because the motion we're seeing is this fast, it's producing this amount of force, blah blah blah, and we know that this planet must weigh this amount because of all the other gravity, blah blah blah, right?" So they already have like one part of what they need to solve for. So now they just fill in the black hole with infinite volume and density where they need to mathematically, and they're like, okay, well now it retroactively fits the orbital pattern discrepancy that we're seeing. Therefore, this like that's how they do it. That's all it is.
Yep.
And this is after they've imposed conditions on the equation that's outside of the parameters for it to be able to explain. So it starts to it breaks down, and it's like equivalent to dividing by 0. So they impose the breaking of it, and then they tell a story about how it has this infinite curvature and the singularity and the mass and density. Like, okay, what? How are you measuring it? Oh, we measure it by the anomalous behavior of objects that defy our model.
Yeah, optically. Like, don't
what?
forget, whenever they look at the sky and tell you anything, all of that, it just breaks down to, like, actually, we looked at the sky, we measured it in arc seconds, and then we guessed what the mass was, and then we used that unit to guess about everything else, and then we made up this unit called solar masses, and then we prescribed everything in the sky based on how big it is to the solar mass schedule. Do we determine mass? And then we invented stellar spectroscopy. Or don't worry about testing it. Don't worry about it. We tell you with stellar spectroscopy, we can tell you from the color of the gas what element it is. Don't worry about the way we measure it on Earth. Actually, is in the atmosphere with that very gas in it. But we can guess. We can tell you what it is 1 billion miles away. Like, come on, dude. All this shit is like the worst lore for a video game that I've never played.
I'm glad you brought up spectroscopy. I was wondering about that specifically, as far as if there were any kind of like kinematic transformations that they use, or any kind of like I guess like what needs to be taken into account for that?
You're not gonna believe this, bro.
Like,
there's an equation, and I lost it on my I lost it on my Discord account because it got deleted or whatever. I used to have the equation because I asked Parks about it one time. So because the Earth is moving, right, that's affecting the Doppler frequency shift, etc. Right. So they, that's their assumption, right? So they actually have a correction that they apply to their observations right out the gate to like recalibrate what they're seeing as if the Earth were at rest. So they've already contaminated it.
You're talking about for like cosmological spectrography?
Yeah. There's a frequency shift correction that they already applied to.
You gotta send me that information. That's amazing.
Yeah, I want to make that a meme. Should pass that around.
I'm actually in the middle of like a Twitter debate about this, so this is perfect.
Dude, I think I argued with Parks what that was, because I kind of like laughed at it, and he like took offense a little, and then I was like, okay, we'll break it down. Like, if I understand it, you can never prove it, and it's based on terrestrial spectroscopy, which you can go there and test and confirm, and then you just extrapolate on that to space and like said some stuff, and he was like, yeah, exactly. And I'm like, yeah, I'm still not buying it. Like that's not going to be enough for me.
That's incredible.
Yeah, there's some additional stuff to it, and then when you realize that they make correction factors to the frequencies that they observe, that's amazing.
That's amazing.
Yeah, they can really get whatever they need to out of it.
Yep. I'm glad I automatically discounted it from the beginning anyway.
Yeah, like you really didn't do wrong there. Really not too much of a loss. So
what else?
Let's see where Benny. Yeah, let's see where we're at here on covariances. I think this is going to lead into another good one, and then we'll skip around for a couple. I think we're about to lead into the Faraday thing. So this is another, what's that thing called, Shane, when you do something and you like have variables and measurements and predictions, and then like one of them gets falsified and like that kind of thing. What's that called?
I think it's like science or something.
Oh, like a science experiment, right? Experiment? So here we're going to look at a science experiment that disproves the philosophy of relative motion dynamically. Yeah, and thus solidifies the lab frame as being the correct frame to start your basis of interpretation.
Nice.
On the Galilean transformations. Okay, we're going to look at electromagnetic induction and look for any violations of relativity. I hope the guys have the video set up, and if so, we can look at the video before I continue with the slides.
Yep, pulling it up now.
The guys. Oh, you're the guys. I should have known.
We're the guys. Yep. All right, so there's no audio to this. There's just some text. We'll just kind of read along and go with the experiment as it unfolds. So in the unipolar dynamo, electricity is generated when the conducting disk and magnet are co-rotating. This seems paradoxical, since in all other cases, the magnetic induction in the cases of magnetic induction, either the magnet or the conductor must move past one another. So one has to be stationary, the other one has to move. They can't be co-rotating to get, like, you can't move them together simultaneously, right? And then it generates something. So the action, and this is like the basis of the 1905 paper by Einstein, where he gets in like on the moving bodies of electrodynamics or whatever. Like this is what he was talking about, for the relative motion and producing different effects and stuff. So this is the falsification of that philosophy right off the gate here. So this action is also non-reciprocal. Rotating the magnet induces no current in the stationary conductor, but rotating the conductor with the stationary magnet does.
Wow.
Shout out to this dude's YouTube channel. I'll have a link to it in the description. He's got a bunch of awesome videos and experiments. All right, the controversy. The paradox has led to the current controversy, which is, do the magnetic lines of force rotate with the magnet, yes or no? The relativists say they do. The Maxwellians say they do not. We will now demonstrate the effect using a 3D printed dynamo.
Ooh, without knowing anything about this, I'm going to say that relativists are stupid and wrong, and Maxwellians are right.
He even
Well,
looks smarter.
Let's see if I'm right.
Dude, it's the beard, right? It's that Maxwellian beard.
Maxwell's the man, dude.
Well groomed, just well-rounded character, Like he's had some rough nights.
We've seen Cyrus give awesome presentations on the historicity of electricity, heavily focused on Maxwell. He also has some of the textbooks that reference his work from like the old mechanical or electrical engineering stuff that like aren't in the schools anymore, that got taken out of circulation. Because the books that actually have the correct electrical field theory aren't even being taught anymore, so we can further be, led astray.
Heck yeah, brother. That's what's up.
I honestly have seen many of my friends with the exact same face that Einstein has right there, right after like a binge.
Yep. All right, so the unipolar dynamo. So we got your stator, your disk rotor, your magnet rotor, and your drive motor. And then you got your oscilloscope over here, and this will be the lab frame when we're doing our analysis later. So the stationary device here doing the analysis is the lab frame. Okay, so oscilloscope has voltage readout and high amplifier gain here. All right, the stator, rotor, and magnet can all rotate independently. Case 1, the disk rotates alone. Positive voltage appears on the oscilloscope.
Okay.
Obeys the left-hand rule. The B field is up. The velocity is clockwise, so the electric field flows to the rim. All right, case 2. Disk rotates alone in reverse. Negative voltage appears.
Okay.
Obeys the left-hand rule. The B field is up and the velocity is counterclockwise, so the electric current flows to the center.
And just to be clear for anyone that doesn't know, the left-hand rule being the idea of the field generating around the magnet, right?
Yep.
The interaction between it.
Perpendicular to the direction of flow to the current.
Thank you.
Or electric current. Yep. And then case 3, a magnet rotates alone. No voltage appears, only scope noise. Case 4, the magnet and disk rotate together. Positive voltage appears.
Wow.
This is what the paradox is. The disk and the magnet co-rotate, but they still generate an EMF. Now there should be no relative motion between them to generate said EMF because they're rotating together. How doth thou just tell if you're rotating and all that, right? Well, turns out this is it.
Like in real life, again, turns out Einstein's wrong and everyone else.
Case 5, the stator rotating alone generates current. As the stator moves clockwise to counterclockwise, the voltage fluctuates corresponding to the motion. All right, for more experiments, check out your boy here on Conspiracy of Light. Awesome website, Sky Hunt. I think that website's down now, but used to be able to order laser printed interferometers off of it. But yeah, cool stuff. So, are we? And I was closing it out like I had a separate video open. I'm just gonna let it play. My bad. There you go.
Nice.
All right, you're good to go, sir.
Okay, I'm back with a small screen and myself in the lower left.
Yep.
Okay, let's see.
He doesn't like that.
Nah, this is where he messed up.
Oh, was
So
this
he-
like the 20-minute breakdown now?
Maybe.
Yeah.
I need the full screen.
We had I think this was after the tech problem, wasn't it?
No, this is
Yeah,
like right
I
up.
think
Oh, okay.
This is like
Thank you.
leading up to it.
That was a bummer.
Okay.
Yeah. What can you do?
Yeah, happens.
I can't control the slides.
Yeah, see, he was in the wrong tab. He didn't know.
I don't know. Yeah, you can if it's not working.
There's no sound on that video, by the way. I mean, in the conductor.
It's not that deep.
All right, when we get back, he's going to get
Oh,
into
yeah,
the
there you go.
gravy. Yeah, we played out the video for you, and then you were.
A second ago from one of my first. Also read atheism debunked.
Wow, this sucks.
One of the
Good
biggest
thing it's
truths-
fast forwarded.
Good.
Want me to start now?
Yes, yeah.
I'm sorry.
Oh, you're good. You're good. Go ahead.
Okay, what we saw in the video was the actual experiment which tests Faraday's law. In this slide called Faraday's anomaly, we're going to see why some of the predictions of Faraday's law are not true. First of all, what is the Faraday's law? The EMF, the voltage produced, which is the generator principle, depends on a charge, Q, moving through a magnetic field, B, with a speed, V, and what we must have is the speed of the conductor, C, relative to the magnet. So Faraday's law originally said you must measure the speed of the relative speed of the copper, the conductor, and the magnet, the iron. What you saw in the experiment was a copper disc, which is the conductor, located directly above an iron disc, which provides the magnetism. A motor provides the capability of spinning either one independently. And up here we have two brushes which pick off the voltage between the inside and outside of the conductor. And as you saw in the video, the wires connect to an oscilloscope, and you saw whether there was voltage produced or not. So I'm going to go through the results of the test for those that are important. In this diagram, oh, come on. In this
His little
diagram,
exasperated
we
sighs
see
keep
a
me
chart of all the possibilities.
If you just kind of like click on the left of the slide, yep, it should go
Yeah,
away. There you go.
all right. The chart shows that there are 8 possibilities
flex.
for rotating disk, that is the copper, rotating magnet, or the meter rotating. We are only going to consider the meter as stationary. So there's only going to be 4 possibilities. Number 2, line 3, 5, and 6. Those are the ones that we consider where the meter is stationary, the oscilloscope. And in this case, the disk rotates and the magnet is stationary. So Faraday's law would predict that there's relative motion between the two. And over here, we see the voltage is correct, as predicted by Faraday's
Dude,
law.
everything that
On
can't
line
go
3,
wrong will go
the
wrong,
disk rotates
or whatever.
and the magnet rotates. Now, according to relativity, the two are rotating together. There's no relative motion, so there should be no voltage. But in this column, we see in red, there is a voltage. So line 3 violates Faraday's law if you use relativity. The other ones that we want to check are meter stationary, so that's line 5. The disk is stationary and the magnet is stationary, and that's no relative motion, and there is no voltage. That's correct. Disk stationary and magnet rotating, that should produce a voltage, but it doesn't. So this is the second violation of Faraday's law using the law of relativity. What I want to look at next.
Dude, you gotta love this guy, man. He really did his homework, right? Here's a
Dude,
handful of multitude of violations of all the laws using the things that the claim to prove relativity actually disprove it.
Dude, so Shane, real quick, from this experiment, is your takeaway that all reference frames are equally valid, or that there's like a preferred, there's one that like seems to stand out above the rest?
I'm pretty sure the lab frame keeps coming back up.
Yeah, the lab.
Fix, dude.
Tell me about the lab frame. What's that?
Now, I don't want to be. I'm not like exactly like an expert at this, but as far as I know, isn't the Faraday formula based on an inductor interacting with a polarized magnet, and the rate at which the inductor goes through the magnetic field will determine the amount of voltage created. So under these circumstances, it wouldn't really be a valid formula with the type of setup that's being used, due to the fact that they're two rotating disks. One is a polarized magnetic field in the center, or opposite sides, I'm not sure. But instead of it being interacting with the magnetic field by traveling through it, it's going with it. So I'm not sure if the formula would really work in the first place. That's the only thing I'm thinking in my head.
Well, the falsification is in the relativity frame, where there's not supposed to be any relative motion between the two to generate any voltage in the first place.
Yes, yeah, I understand that. I'm just saying, like, it seems as though the formula wouldn't work in the first place, just period, due to the experiment that was utilized to originally formulate the formula. Formulate it.
That lab frame, man, keeps coming back up.
Because as far as I know, it was an induction coil interacting with a polarized magnet, and what they did was they changed the velocity of the magnet as it traveled through it, and then that was how the formula was formulated. I don't know why I keep saying it like that.
Well, it seems that pesky lab frame dude keeps coming back up whenever you got to make like measurements or things apply to reality.
Yep.
Is the summary. When the disk spins, we found that the test agreed with Faraday's law, and so did special relativity. Now, if I use, instead of the relative motion between the conductor and the magnet, I use the motion of the conductor relative to the Earth, the lab frame, that also agrees.
Oh.
When I consider the magnet was spinning and the disk wasn't, then I get no for special relativity, and that doesn't agree with what the experiment shows, which when they both spin, there should be no EMF produced. So there are two conditions in which Faraday's law are violated. But if I use, instead of conductor relative to the magnet, I use the conductor relative to the laboratory, I do correctly predict the voltage, the generator principle. So SR in electromagnetism is rejected.
You mean like
the alpha
every
model,
time?
meaning one
It's
in
like-
which there is an absolute
No.
lab frame corresponding to, which predicts correctly the results that we get. So we see in mechanics and we see in electromagnetism that the lab frame must be used in order to predict correctly using the laws of physics.
It's like, as he says it sounds silly, because it's like,
Right,
dude,
it sounds so basic.
but it's like,
commonplace.
but it has to sound silly because he's refuting something so freaking goofy.
Yeah, man, they stacked on so much nonsense and so much complex abstract mathematics to like obfuscate all of this, and like made the barrier for entry so high,
Yeah.
and deified Einstein and put him beyond, reproach. You can't criticize him. You can't, the guys they literally do articles where they're like, guys, when Einstein was wrong, he was actually right. Like, that whole gravitational constant thing that he may or may not have put in his equations and stuff, and then like took it out, and then they were like, oh, it turned out we discovered dark matter, so he was right the whole time. Like, they'll retroactively change his work to make him correct. It's insane.
Dude, they would do all sorts of shit to hide it, right? Like they will attack you if you absent, if you disagree, they'll call you names. They give them like the Israel treatment, dude, right? If you don't know, then you're just dumb, you're ostracized, you're excluded, you don't get it. You certainly don't get funding, you don't get this, you don't get promoted, you don't get a job, So everyone goes along with it. That's how they do.
Yeah. And then, so we're going to get into the vector potential thing, which is the cool mathematic thing real quick. So how they're all about elegance in the mathematics and such. So check this out. You can eliminate two of the equations or whatever if you just have the Æther vector potential, because you can derive it backwards or whatever. It's pretty cool. I don't really fully understand it yet, but hopefully we'll start to make sense of it here. Actually, I think we have a vector potential specialist in here. Eric E, are you in the building, sir?
People don't like
All
to
right,
be
cool.
called out, Alan.
Well, I wasn't trying to put him on blast. He's a good dude, but he might know a thing or two about vector potentials.
Well, I'm
Hey,
here.
Alan,
What's up? Do you
did
know
see
anything about vector potentials, my dude?
Oh, I know that in Feynman's lectures, he goes into the vector potential, and I believe he claims that it's not just a mathematical construct, but that they actually do have their own existence, even though they you derive the H and B fields from the magnetic vector potential A. So that's probably all I should say right now. Feynman gives the case that they actually do have physical existence.
Cool. All right. So there's a little bit of pretextual vector gravy. Thank you, sir. We'll play out the video now. And if you have any other vector things you want to chime in about, please feel free to.
That was just discovered recently called the vector potential. I identify it with the ether, which is why I call it the ether vector potential. A quick review of what vectors are. A vector is something with size and direction. We indicate it with a bold letter. The vector could be representing a line in space, or it could be representing something rotating. The way we tell it what's happening, we use the inverted delta operator. We use the nabla. The nabla applied to a vector indicates whether the vector is changing in shape or in space. So this is called the gradient. The nabla plus a dot applied to a vector is called the divergence. That tells you if there is any radial change in the vector. In other words, is it getting bigger or smaller? The notation with the nabla and an X is called a curl. The curl tells you whether there is a change in the rotation of the vector. So this is a way of conveniently telling us, using mathematics, whether a vector is getting bigger or smaller, or whether it's rotating, or whether it's constant, then it would be 0. So the curl finds everything that is rotating. If we apply the divergence, as we do here, then the divergence finds everything that is radially changing. Well, the first one eliminates all expansion, the curl, and the divergence only picks up what's radial. So the two together must calculate 0 for the amount of change. So this is an identity that's always true. For example, in Faraday's law, if you wanted to interpret this, you would say the curl of E indicates that the electric field has what? A rotation. So if the curl of E is not 0, then there must be a change in rotation. And this must equal the time rate of change of the magnetic field B. So this is how you can look at Maxwell's laws and interpret what they actually mean. We know the divergence of B is equal to 0, which means magnetic field lines never end. They always consist of circles or loops. Suppose we let the vector B be the curl of some vector A. Now, mainstream picked A as the symbol, but it's interesting because ether is what it really represents. If B is the curl of A, then the divergence of the curl of A must be 0 because of this identity. If we use the other Maxwell's laws, we find the electric field is the gradient of a scalar potential phi.
Yeah, same. So we'll just.
I'm glad I'm
I
the
was
only one.
following, like, no, I'm out. Can't do it, guys. Sorry. If anyone's following, let me know.
Yeah. Okay. Cool. I'll come back to it after some extended research. You got anything, Eric?
Well, it is complicated. You have to look at it and study it for a while, but it's not insurpassable to understand. But now, after I spoke, I remember what Feynman was saying. And, he was saying the vector potential has physical existence of its own. And I believe, and you know what, I'll look this up for you, Alan. In his lectures, I think he does refer to the unipolar generator as an example to show that the A field does have physical existence. So I'll look that up for you. I'll give you.
Ooh, okay. Gravy, dude. That's what's up. Thank you.
Yes.
Oh, cool. Robert Bennett. Dude, Bennett's in the chat, dude. Shout out to your boy, Robert Bennett.
Is he?
Excellent. Yeah, he says the bomb Armanov, the Russian guy, shows the vector potential has a real existence. Awesome, dude. So we'll get into that.
That is what he was saying.
Yeah. Fuck. I hate.
Yeah, but just so everyone knows, like, I have no idea. I followed about 10% of what he was just talking about there.
Yeah, we'll have to come back to that one.
Like he said, it measures the rotation. He's a symbol that measures the rotation of the movement. So if it's not zero, you know it's moving. But then he had another thing of itself referencing the movement of itself, and I lost it. It was like a refractive loop that went recursive on me, and I'm like, my brain didn't. I just kind of went out.
Yeah. Well, like I said, it's there's definitely gravy there. We'll come back to it.
We'll have to be
And then
deciphered.
we'll look at the other experiment that he was referencing real quick in the chat. Oh, he gets into it right here. So the vector potential. So let's see what's up with your boy vector potential and see if we can get in here.
From the vector potential, I can determine what the values of E and B are.
Yeah. Yo, we're gonna be having Robert on soon, like on one of these Æther talks.
Nice. Yeah, you should definitely just hop on at any time. Mr. Bennett, definitely welcome. We all have lots of respect for you.
Dude, so here's the thing. I was supposed to get him set up with Discord and stuff. Didn't follow through with it.
You know it's hard, man.
I shit the bed on that, so I apologize. But I'll get it done. So
nice.
So here we go. We're going to analyze the in this and see if we can figure out what the vector thing comes from.
Now, there's an experiment that recently was done which connects electromagnetism with quantum mechanics. It's called Aharonov bone test. If you have a solenoid, an electromagnet, it produces a strong magnetic field inside and almost zero outside. If we ask what happens to electrons when they go around the cylinder, then that's predicted by Schrödinger's equation. So this is quantum mechanics being applied to a classical electromagnetic case. Electrons are being sent around a electromagnet, a solenoid, and we can ask what are the predictions that quantum mechanics makes. The diagram down here shows that if we set an electron beam, two of them, through a barrier around the magnetic field of the solenoid, then the magnetic field, according to theory, it's non-existent outside the solenoid, so there should be no effect. But quantum mechanics shows that there's an interference pattern if I combine the electron beam from the original source. What this means is that a classical electromagnetic theory would predict that there is no effect on the electrons, but quantum mechanics says, yes, there is, because we see an interference pattern. So this proves that the A potential, the A vector potential, must be used in order to predict correctly what happens in this case, which is predicted and confirmed by quantum mechanics.
Dude, so think about how tangled this is now. Where now it's now there's the quantum mechanic effect that verifies the vector potential of the field. Like, yeah, we're gonna have to come back to digest that, the magnet and stuff.
All right, GPS.
All right, so here we go, Toby. Spoiler alert or whatever from earlier. Shane, this is crazy, dude.
Does he do a better breakdown than you do?
Brace yourself. Yeah, dude, complimentary, and he explains why Wang like this makes sense why Wang didn't answer anything about the ECI reference frame because of what like the actual importance of it, dude, is like just wait till you see what they do. It's actually genius. I'm kind of in awe.
All right, well, we built it up.
GPS is considered and promoted as a proof of relativity. Well, let's see if that's true. We have already tested with GPS satellites whether if you send a signal all the way around the Earth with a group of satellites, that nothing will change. And the reason nothing changes is, even though there's an Æther field, the speed is c plus v all the way around, so there's no change. If you do the equivalent of the Michelson-Gale experiment and you use the GPS satellites to send out two beams at the same time in opposite directions, then this should be familiar. This is the Sagnac effect. When the beams return, if there's a difference, then we have an interferometer effect, and that proves that there is an Æther speed that's affecting the path of the light. Now let's apply that to GPS. GPS works by having a ground station connected to a satellite with a communication between them, and then down here is your receiver, the pocket version of GPS that you use to determine what your position is. What we claim for an Æther model is that when the satellite is in different positions, the effect of the Æther on the signal will change. When it's on the horizon is different than when the satellite is directly overhead. So what you should imagine on this line right here, which represents the signaling between satellite and ground station, that the speed c is equal to the speed the speed of light is equal to c plus the speed of whatever the ether is at this location. So if you correct for that speed, you can use c as c times t as the correct distance between the satellite and the ground station. And so that's the interpretation of GPS using ether. You must use that to correct the signaling between both of them. Now, what does the conventional or mainstream explanation consist of? They say, in order to use the GPS system, you must use the ECI reference frame. ECI stands for Earth-centered inertial. In other words, the star frame. If you were in the ECI frame, you would see the stars frozen above you. They never move because the Earth would be moving with the stars. Or if you want, the Earth and the stars are moving together. And so relative to each other, their speed is 0. They use GPS time. In other words, they don't use the time that we use when we measure the rotation relative to the sun or the stars. They correct for the motion of the stars using the so-called ECI frame. It's Earth-centered, but it uses the stars, not the Earth, as the reference frame. The ECEF is the Earth-centered, Earth-fixed frame. That is the frame that we're used to, the one that uses the motion of the sun and the stars in order to set our clocks. If you use the ECI frame, what you're saying is that the stars never move. They're always overhead, the same stars. What that means also is that the solar day is no longer 24 hours, but it's 1 year long. In other words, if you were really in the ECI frame, it would take 6 months of daylight and then the same number, 6 months of darkness with light at night in order to agree with what you see. If this were true, then we would have lunar.
Yeah, dude. So I had
That's a different interpretation. Yeah, okay.
Dude, I had a misinterpretation of these two frames. But then wait, it gets even better for the significance of the transformation. Because it's like it doesn't matter necessarily, like it's still, fine or whatever. But now that we have the correctness of it, watch when we get to the significance of it, it's gonna
tides that change every 6 weeks, not every 12 hours. And if you've ever seen the movie The Earth Stood Still, Hollywood has actually taken this idea and shown that this would produce tremendous winds across the surface of the Earth because one side of the Earth is 6 months in darkness, while the other side of the Earth is 6 months with direct sunlight. So obviously it is not observed. All of these changes that I list here are not what we see. And yet they claim this is the frame that you must use in order to make GPS work. And the reason they have to do this is that by using this frame, you're using a frame in which ether speed is 0, and therefore the speed of light is c, not c plus phi. So ECI is a fantasy frame. It is used by mathematicians who think they are physicists, but it doesn't correspond to reality. The ECI frame that is used for GPS calculations is not the frame of reference that we use in order to do ordinary physics.
In other words, not the lab frame. It's not.
No, dude. But yeah, so just wait though. So, but remember though, when they transform out of that frame, they have this remainder, right? They have this thing that breaks their covariant transformations with the speed of light from a coordinate system that they established that's rotating with the ether, so that they can remove that, but there's still a remainder. So what they do when they transform it to the ECEF, that remainder then becomes their velocity correction, right? So you know how, yeah, dude, they already inherently have it because I actually went and found the documentation where it says that there's a Doppler frequency shift proportional to the velocity of the receiver, which is them admitting that the speed of light changes proportional to the velocity of the receiver, which they obviously can't say. So nowadays in the ICD documents, they have like a diagram, and then on like one side of the diagram, it's like this is where the signal starts and GPS time, blah blah blah. And then it's like by the end result, we have this velocity correction and all this shit. And it's like, how'd you get that velocity correction, bud? And it's like this is where it came from. It's the remainder from the transformation. They invented that fictitious frame to hide the ether effect. Like he gets into it, but it's like it's insane, dude.
I was asked about E equals MC squared.
All right. So before we get into E equals MC squared, I'm going to jump ahead to where we finish up the GPS thing, because towards the end of it, me and model builder figured it out, and because we were talking about it in PM, and then I asked Bennett about it, and he was it turned out exactly as we thought. So you skip ahead here to 2116.
Your what adversary is referring to. Relativity was just a way to keep the model in place pretty simply, and everyone can conform to it. No one can come up with an alternative, so it stays in place. It's pretty much. So I'm not really sure who you're referring to as adversary. Okay, we got another question for you here. Did I understand correctly that they made up an ad hoc arbitrary reference frame to explain GPS clocks?
Yeah, basically. If you want to go into the details,
I like
GPS
that
was
matter
built
of
by
fact
engineers,
answer.
not by physicists. If they claim that they're using theory to explain how GPS works, well, no, that's false. You know, engineers are different from, and I was an engineer for 20 years, at least, software engineer. Engineers get paid not on theory, but on delivery of a working product on time. Okay, so that's all they care about. They don't care if 2 + 2 = 4 or 2 + 2 = 5. Whatever they need to make the system work, they will do it. So the way GPS evolved, actually, if you read this, and it's on the internet, they basically fiddled with different ways of detecting what is the distance to a satellite. Because once you have that, then you can use that to locate any ground transmitter that's transmitting to the ground station, and you can communicate the location through the connection with the satellite. So they fiddled with this, and I think I mentioned Ron Hatch was one of my colleagues. He recently died.
Oh yeah,
but he worked on the GPS system, and he revealed that basically they just kept fiddling with it until it worked, and then they had to figure out what did they do that made it work. And they said, well, we can't use Æther because nobody believes in Æther, at least none of the mainstream people they're working with. So let's see if a different reference frame can be used. So they said, well, let's consider that the GPS system is in the ECI system, the one where the Earth and the stars are not rotating. And they found that that worked. And I can explain why that worked, because if you use the ECI system instead of the ECEF, the lab frame, what you're doing is saying, I'm going to take the Æther that actually rotates around the Earth, and I'm going to make it stationary. Well, if you do that, the speed of light is no longer c plus v, it's just c. In other words, they put themselves in a reference frame which rotates with the Æther. That's what I'm saying.
Yeah.
And if you do that, then you get the correct results. But that's not the world in which we observe.
And
we don't see the sun on one side of the Earth for 6 months, and then on the other side for 6 months.
And that's where they
and all
do
of these
all
would
their
be true
equations,
if we really lived in
predictions.
the ECI system.
Oh my God.
Now, there's a lot of details, of course, but that's the basic gist.
Oh my
GPS was
God.
built by engineers, not physicists. The ECI system works because it assumes that the Æther is at rest, which is what you do when you say the stars are not moving. And that's the explanation that I would give, without going into details of
Oh my God, dude.
what was the history of GPS.
That's so
It's
succinct.
not a confirmation of relativity, definitely not.
Definitely.
Yeah, and
the
it's funny that
best-
that's actually what people say too. They actually say GPS is evidence for relativity.
Well, you can't
Definitely
blame people, Austin, because they're just repeating what the media tells them.
Yep.
I can blame them for doing that though.
Best
Blame me a
super
little
chat
bit.
I've ever
Yeah,
bought.
I blame them for not thinking. Yeah.
So real quick, can I get into some details on the transformations on GPS, right? So are you familiar with how they say that the velocity of the speed of light is proportional to the velocity of the receiver? Like there's a delay. Are you familiar with that?
Yeah, these are all of the original theories that were used to try to explain the optics experiment, measuring the speed of light. Yeah.
So what you were saying with the transformation, the way that they would cut that off in the transformation, they would be able to derive the velocity of the receiver and then like tell everyone, or like not ascribe it to the fact that they just derived it because it's proportional to the medium, that they were moving through, right?
Mm-hmm.
Like that just blew my mind because that's crazy. I didn't fully understand how it worked, and I had a slight misunderstanding on the ECI frame. And what you just said, just like it's over. That's how they do it. Because I was looking at the new documents because they used to actually say in like the 1990.
All right, and that's kind of where I just put it all together, where I was like realizing it.
Nice.
With that, how they got that velocity correction, because they just have it in the diagram. Like, here's a velocity, because they completely removed the terminology like proportional to the velocity, like all that stuff gone. Because
Well,
like,
they didn't
if you
have
search
to
it,
because their frame, everything stays still.
well, no, they did have to remove it because it's pretty plain English. Like that's plain English that the speed of light is changing proportional to the velocity of the receiver, which there's no mechanism for that in their paradigm because there's no Æther. So there's no absolute motion to be relative to. So there's no way that GPS could even functionally be that accurate unless there was an Æther. Like that's why he was saying they had to keep trial and erroring things, and then until they got to the point where they were like, let's use a frame where this effect isn't happening, and then when we transform it, we'll take the remainder out and call that a velocity correction that we just got out of thin air to disguise it. But yeah, in the 90s, the ICDs used to say that there was a Doppler shift frequency proportional to the velocity of the receiver, which is like GG, right? But then they just show you a diagram now that has a velocity correction at the end of it. And it's like, where'd you get that at?
Show me.
Well,
Where'd
actually,
you get it at, buddy?
what they do is they show you 10 pictures of other unrelated things, and then they throw in the correction at the end, and you're like, okay, I guess that's where you
Yep.
got that from. Oh, okay.
Yep.
Very misleading.
Yep, super significant. So yeah, that was awesome. To have that under the belt now. So it's like, yeah, it's just and then I got, obviously I got the old documents and I got the new documents. So
It's nice to have Bennett corroborate many of our things and correct a couple of our other positions, so that now we can actually like theoretically attack it correctly. I think he's awesome.
Dude, it's great to have that. it's such a great resource, man. So let's see if there was a couple more things.
I'm glad we're doing this because I had forgot. I definitely want to clip that, man. His answer to that question was so succinct.
Yep.
Yeah, you should make notes wherever you make your awesome clips that this timestamp. You should clip that. Gives a succinct explanation, 2 minutes, and let's put it on Twitter.
Yeah. Yep. There's a really good evolution debunk that was funny. Some good rhetoric in there. Where according to the evolutionists, a fern should be the most advanced organism on the planet. So that's cool. Yeah, I think that's all I got for that. How long we been live, Tobitheus?
We've been going an hour and a half now.
Hour and a half? All right.
Well, we do have many more people here than we usually do. Maybe we could do some open discussion and then do another one and then follow up with the second half of the maybe.
Absolutely, bro. Yeah, dude, I didn't even realize how many people we got in here.
Yeah,
dude,
turned off your beeps when you're streaming, but I wasn't streaming and I heard them all come in. Welcome everyone. Good to see y'all.
Welcome.
What's up?
Hey.
Good to see y'all.
What's up, JT, Dave?
What's up? I had no idea what was going on. I just found out clicking through YouTube, and all of a sudden, oh my god! How did
I feel bad throwing it in Flatman's. I haven't even been over there to say hi yet.
What's up, actually, I sent you another invite. Flatman's kind of split up, but yeah.
Oh yeah. I always join what Dave sends me. You gotta follow him around. He's always plugged into the hippest spots.
Trying to figure out, always trying to figure out what's going on in all the different areas. I am gonna have to go back and watch the first hour. I don't even know how to participate in what you guys were talking about.
Well, did you watch? Did you watch Bennett's thing last week? Robert Bennett on Witsitgetsit?
No, I still haven't yet.
So we've been going through that. So you should definitely either watch this or that. Probably both, really.
Okay, I'll do that. Other people here want to say something?
Did you watch Bennett's other one, or you watch our breakdown of it? Right.
Yeah, I just did the breakdown. Yeah.
Dude, honestly, but the first time watching it, like with Alan coaching me and bringing him to his specific timestamps, is kind of ideal. I'm not gonna lie. This is a really good viewing experience.
Yeah, I mean, it's probably best. I mean, I'm glad I did both, but yeah, I definitely missed a bunch of stuff both times, and then it's like Alan's just like here with notes and like, yeah, it's perfect.
Well, I remember the first time no one even interrupted Bennett for like 2 hours. And then they came out of the woodwork and they were like, oh, we can talk. I was like, where were you guys? Were you even like there? Like, you must have felt so alone. What is this? What are we looking at now?
Looking at a new ICD that Eric just sent me.
Something else that's using the ICE? Or the EC? Wait, sorry. What's IC?
No, it's a GPS document. I'm just looking to see how they have it rotated because I got a couple here. I got the government. So I got this one from '96, where they say the Doppler shift of the frequency of the receiver carrier signal is proportional to the relative velocity of the receiver with respect to the satellite along the line of sight from the receiver to the satellite. So direct one-way variance in the speed of light where it's proportional to the receiver's velocity. And then they dress it up. So in 2006, this is how they have it shown now. They have a diagram here where it just shows GPS time and then the direction of flow or whatever. Then it's just like, here's your user position, velocity, and clock bias. It's like, where did you get that at?
This is something like a mainstream like Globe Troll would just present to you as if it refutes you. You're like, well, actually, now that you bring it up, let's focus on where you get that remainder correction to add.
Yeah, it's like, where'd you get it, buddy? It's like, oh, you got it from the transformation. Nice. Where you were assuming that the ethers and Earth are rotating together, even though one of them is clearly not.
Well, so is that what is that what the box is? It's like literally a box, filter, and coordinate converter.
Yeah, it's just a
magical box where we run our magical equations.
The old filter and coordinate converter, bro. And then the output is user position, their velocity, and time correction.
Yep.
Indubitably. So that's all very cool. And then I think, where's this one? This one is from, I forget the year. Yeah, okay. That's what they started diagramming in this one as well.
Dude, so Earth-centered, Earth-fixed. That's the ECEF. That's the one where you think that you rotate with the stars in the 6 months of sun and darkness. Is that what he said?
No, so
or did I mix them up?
The ECEF would be the proper coordinate system in regards to the rotation of the sky. And then the ECEF would be a fictitious coordinate system where it's technically from the perspective of saying that the Earth and the sky are rotating together so that there's no difference between them. Does that make sense?
Yeah.
So it's basically just saying, like, in this specific frame, the speed of light will be the same. And then as soon as they transform out of it, they have that remainder. So they just, because it always bothered me why they had to transform in the first place. If it's because, Wang points it out that it's like accurate to the millimeter in the first thing, and it's like, why do they even do that in the first place if it's already GG?
It should bother everyone.
Yeah, and it's like, this is why.
It's like, hey, I took this first order measurement, but I got to apply some corrections to it real quick before you can see it. It's totally real and it comes out the same. Don't worry about it. Trust me, bro. It's like, what?
Yep.
This is a silly question, but when it says Earth center, Earth fixed, is that in relation to where it is or from the center of a globe Earth?
Earth, who knows? I have to go look at the definitions again. After I misinterpreted them both, I have to go reread them both now.
Dude, the way that he diagrammed it out, it looked like it was at the middle of a globe.
That's what that's when
you
look into that Earth-centered, Earth-fixed. It seems like it takes it from just a point.
Right. Well, it has to because it's just the coordinate system. So like it's just an arbitrary point though.
Yeah.
To start it off. Let me see. My GPS presentation. You guys see this?
Yep.
All right, cool. So you got your boy Earth-centered, Earth-fixed, your ECI, and then you got your Earth-centered, or actually I said that backwards. So the ECI is over here in this one. So let's see what the animation says.
Centered inertial equilateral. So that's what everything's rotating with it, right? So it's like all moving at exactly the same.
Earth-centered, Earth-fixed. Okay. All right. So the stars are static and the Earth moves, and this thing. Whoa.
Yeah, see, this is why it got confusing for me to try and interpret all of this because it's like, what? Because I thought that this one was stationary with respect to rotating stars, and I thought the other one was rotating with respect to stationary stars. Which I think I haven't even defined like that, too.
Didn't Bennett have a slide on it? Like, how did he put it? Because I felt like I understood it when I was looking at his picture. Yeah, back. Right there. The picture of that one. Yeah, what's that say? The one that it made up. He said the ECEF is the one that's made up in nonsense land.
No, the ECI he says is the nonsense land. Because in that one, the way that they have it stationary, their interpretation is stationary. Yeah, hold on, I'm about to get you.
Even like during the presentation, it was like half of a screen within a half of a screen. By the end of it, Looking at when you're streaming on Discord, it's like 4 inches, even on my giant monitor.
Yeah, I got you. I'm about to get you the actual slide, bro.
Hey,
Well,
there
so
we go.
I think it's so. My understanding is that the Earth-centered inertial means that everything. It's like everything is rotating perfectly with it, right? So that it's basically you can then, from a relativistic framework, the speed of light would be constant because everything would be, rotating exactly the same speed.
GG.
Sounds appropriate.
That's what they did.
Yeah, that's.
So here's a screenshot, Shane.
That's
of
his
that,
slide,
and then
Oh yeah, solar day, the one that's what 6 months of day and night, is the one that's stupid.
yeah.
Not observed, big red letters. See, that would have been super clear. I was able to read it.
Yeah. All right. Cool. So, does anyone else have any? Yo, shout out to my boy Sacred over there. I see you. Pull up to the Æther Cosmology. What's up?
Yo. What's up, fellas?
Yo, welcome.
Appreciate y'all having us. See some of the level heads in here. Showing some love, of course. Y'all got some real sauce over here, man. No lie.
Yeah. Dude, yes, I see lots of people from level heads pulled up. Dude, this Proud Sheep and who else? That's all I recognize is those two other people. But anyway,
Ken is in here too.
who's that?
Ken.
Ken. Oh yeah, shout out to Ken, my boy Kenbo. Yeah, did you guys have any questions for the Bennett thing or anything, or Æther questions or questions in general?
How about people who still question Æther? We should have some of those. If any of those people are around.
Yeah, we haven't been doing much to outreach.
Dude, yeah, our community outreach.
We got to
is
get
zero.
some opposing viewpoints for all Æther rabs sitting around in a circle jerking.
Bro, all the flat earthers that don't believe in the Æther are too toxic to even have a conversation though. So
That
it's
is
just like
true.
I don't even know.
That
Yeah,
is
I don't
true,
even know
right?
how productive it would be.
That's a weird correlation. I'm glad you brought that up. That's strange, right?
That does seem to be the case.
It's like, tell me what the Æther is. Is it a unicorn fart? It's like, well, no, but like we have all these effects that we could measure that have a specific variance to that matches
like you guys
sidereal
don't like
time. So
measurements?
yeah, there's a proportional delay relative to the velocity of the observer in GPS. Like there's all these red flags for a medium of which is absolute that everything's propagating through,
Yeah.
and it's like
why would
no.
No, dude,
why
you're
would you
not supposed to.
dismiss-
You're not supposed to want to have a philosophical framework to interpret the science of the world you live in.
Right? Or no, because they
The
have their
issue with
imposed
the-
philosophical framework of atomism anyway, right? That's the
Well,
direct
yeah.
opponent to Æther, right?
Well, yeah,
You gotta have atomism.
you're either an atomist, right, or you're like an Einsteinian, or
Yep.
you refuse to even talk about one or the other, which to me is insane because how are you're just gonna not allow yourself to conceptualize or try and learn about what's happening physically in your world? You
Or
have
then,
to have a philosophical framework to even
like if you choose
do
like a
applied
fantasy
science
framework,
in a lot of cases.
if you choose a fantasy framework to interpret things and then start to do science and experiments and do things that depend on the said science, but you're often mathematical nonsense land with atomic probability clouds and electron shells that may or may not be there with devolving electron like that. None of that shit matters when you have to engineer and build shit and actually come back to the lab frame. In reality, actually, it turns out you have to work with not light isn't a duality particle beam wave that depending on whether he's looking at you or not. Like no. It turns out it's none of that. Nature doesn't exist in dualities. Everything's an Æther, right? Everything moves through the Æther, including light.
So you're
Bro,
saying
we
that? Oh, sorry, go ahead.
Oh no, go ahead. I was just about to say, the globe earthers, we had 2 whole spaces on that. Like they don't even want to talk about experimentation anymore. Like we had 2 whole spaces of the flat earthers saying, yo, scientific method, experimentation, and the globe earthers say, we don't need experiments no more. It's only about observable studies. Like, that's crazy.
Oh, yeah.
Dude, why would you throw away Dayton Miller 5,200,000 experiments into
5
experiments?
million, bro. That's crazy.
Corroborating all the things that we say and claim. It's like, yeah, let's keep him though. Let's not, throw him away. Let's keep him around just in case.
Yep.
all those flat earthers who don't like Æther are discounting all of that data, all of these measurements, all of
it's
this
like-
solid heliocentric refutation. Like, I don't understand.
If you're a flat earther, like, you're aware that that society is indoctrinating into people in a specific way of thinking that is, possibly bad for them, right? Like, it's bad for your ability to process information. And so we know there's an indoctrination happening. We know that people are wholly accepting this. So why would we not want to then look under the hood and say, hey, look, they told us that everything is separated from everything else, like to the most like microscopic, quantum level. There is just empty space, and it goes all the way out into the cosmos too. Just empty space, empty space, empty space. Everything is separate. Nothing is connected.
Wow.
Like, you either accept that framework or you go the other way, because there's really no in between, and everything is necessarily connected. But we don't want to talk about that. That's insane.
Right? Dude, if everything is separate, then, then you have, nihilism and meaninglessness, and everything is away. You retreat towards yourself, and you go ego, and then that takes over, and then you have selfishness, and then you have literally like the path to evil unfolding, narcissism, and then the path to no God. And then on the opposite path, you have, creation and everything, you're divine, important, at the center of everything, the direct polar opposite of everything to that on every level. Which one would you prefer to live in? Like, which one would you like to be real?
And I say,
Toby and I were just talking about this last night, and I was saying, yeah, it's just like allopathic medicine compared to holistic medicine, basically.
You're talking about like energy medicine and homeopathy.
Well, just seeing the body as a whole system. Everything in your body is connected. I'm not going to go into the microzyma right now, but yeah, if everything in your body is connected and it's all an intelligent, at its source, it has an essence of intelligence that's in communication with the rest of the cells in your body and even further out. But if you see the body as a whole system and you're looking at it holistically rather than allopathically, where you're treating each part of the body separately from the rest, then it's similar in that way.
So like the whole thing with Æther though, right, is they took a scientific like pivot point, and they sent everyone in the wrong direction. If you want to do experiments and further science and try to do energy experiments and build cars and shit, work with electrons and protons and neutrons and fake particles and probability clouds and go have fun. Right? If you want to do like real work, you have to retreat to Maxwell and the true electrical field theory and the true Æther dynamics, and then you can actually build shit like GPS that works and is measurable. Right? So those are the two options with Æther, I think.
Isn't the reason why the mainstream doesn't believe in Æther because it was supposedly discounted by the Michelson Morley experiment?
Yeah, if you read Wikipedia, that's what you will conclude. I think that's so funny, is they had to like rewrite that whole experiment. Like they had to revise history to say what their goal was, to show the mainstream people, here's why there's no luminiferous Æther.
Yeah, because they measured a slight Æther drift. And so it was because it was nowhere close to an orbital velocity that they anticipated. They then had to, you either would have had, at that point you have a fork in the road. You either throw the whole thing out and make up some reason that you don't want to believe it, or you acknowledge that you have nowhere close to the motion that you predicted.
Right, so that's a really good point, dude, because the only correct interpretation of the results of the Michelson-Morley is to say that the Earth orbits the sun much slower than what we anticipated, because they were trying to measure Earth's orbital velocity. They got half of an Æther wind drag, right? So the measurement was so much slower, and then later history, they retroactively claimed, actually, we were measuring Earth's rotation, that's why. And it was only half of what we wanted, but, we'll do it the other way, and now it equals out. That's what that's all about. Now we can discount the Æther. Completely wrong, complete misinterpretation, and a bastardization of what that experiment was all about.
Bro, how do you become a Wikipedia editor so we could just go edit the article to make it show how Æther is actually something that's a real thing?
I've tried that.
I think you have to join the NSA.
Yeah,
Oh,
or you just
shit.
got to build your own
Yeah.
Wikipedia.
I've put truth there and like for flat Earth and like COVID and stuff, and it's gone in like 4 seconds. Like I was like hit refresh, poof. It's like oh shit.
How come
It's
Sacred
insanely gay.
It's funny you mentioned that because Bennett was talking about that at the beginning.
Oh, yeah.
He tried to edit Wikipedia for the Sagnac effect, and they basically had like a jury trial, and he had to present his evidence for the edit, and they denied him.
Yeah,
like he literally.
No way.
Yeah, bro.
Who's making these decisions, bro? Is this a Wikipedia board? What the hell?
Exactly,
Google
bro.
probably.
Exactly.
All of the major like Google, Wikipedia, all of them they're all censoring right now, and they're all on this like whole thing like if you don't agree with authorities and the World Health Organization and the governments on what is official and what is proper science, you can't post it. They're all on that thing right now. So
100% true. And people like Robert Bennett, who are actual like representative, respectable, authoritative PhD holding, doctorate holding people have experienced that the same way, and then it wakes more people up because we're used to it being conspiracy theories. We're shunted, banned, shadow banned, disgruntled, demonetized everywhere we go. So it's fine. But the people who aren't, who are still stand-up members of society, are seeing this and going, "Hey, what the heck?" So that's great.
Yeah. Yeah, like you can't even scientifically provide evidence for why you want to edit the Wikipedia thing on the
they're not
Sagnac effect.
interested in the truth.
Yeah,
Everyone's
because
seeing that.
because if they told the truth about the Sagnac effect, like it falsifies relativity theory. Like
I
in
think
Einstein's
it's deeper.
own words.
I think it's deeper than that. Maybe in academia that might be the issue, but I think it's deeper than that as to why they don't why they're censoring and why they won't accept the Æther. I think it has to do with a lot of I don't know if you've been paying attention to what's been going on with the government lately in the Pentagon, but acknowledgement of the Æther, and in particular things that Nikola Tesla and what's his name, Ed Leeds Scalman, and a lot of those old guys did, will bring attention to certain classified technologies.
Maybe,
that
right?
they're
But I
not
think
ready to discuss with the public. So
I think that's what like old technology was, like the old world and stuff. Like they had etheric energy that they could pull from nothing and just use it to power things, and then they covered it all up, like removed all the tech, and then now we're in the back ages where they can sell us energy and the air we breathe, even though it's pulled literally from the air from everyone around us. I think that's how it works.
but they've actually weaponized it. There's a there's a declassified document from the FBI where the U.S. military was demanding that the FBI turn over all of the documentation they had on Nikola Tesla's works to the military so that they could use it for weaponry. The government knows about, or I should say the American government knows about the quote alternative physics, and they know about the Æther. They've weaponized it. They have weapons based off of it, and they don't want the discussion to be talked about. They're against that. That's why I said it goes deeper than just academia not wanting Einstein's relativity to be wrong. It's deeper than that.
Well, certainly, and I think even if there wasn't a direct usage of that specific science, which I'm not arguing one way or the other, there's certainly a lot of people that would agree with that, and I've heard similar. But either way, and
there's dead proof. I'll post the book.
Yeah, you can drop the docs for sure. But either way, it's like even without that, it's like it keeps us stupid, right? It keeps us from being curious. At least for me, I know it definitely had that effect on me growing up. When you hear, about this relativistic reference frames that everything's being measured from, and I don't know, the outer space is just a bunch of like emptiness, and then there's emptiness between everything down to the quantum level. It's all very it kind of makes you uninterested in science to an extent, and uninterested in the truth about our world.
Dude, everyone already discovered the electron, Toby. There's no more electrons to discover.
Yep.
Right, dude? But like, I keep thinking like the way that they've diverted everyone who has like a scientific mind and wants to experiment and progress, humanity, invent things, be useful. They've given them a whole set of broken fucking tools and pointed them to a dark shit that's broken. Like, here you go, have fun.
And then sat them down in front of computers.
Like, here you go. There's atoms and electrons and probability clouds, and it may or may not be there. It totally works. Everything's particles. Nothing's matters. Go ahead, have fun. No wonder we haven't progressed anything in whatever so long, and technology is like stagnated except for like the internet.
Dude, they progressed the hell out of the
particles matter.
Because if they taught people like the Maxwell foundation for electrical field theory and like all the derivations and how like actual electricity works and how energy works, like people would be off inventing stuff and wouldn't be relying on fucking like oil, right? You got to think. So that's not in the best interest of society. So all that shit is repressed and not taught. And they bought all the institutions and own all the textbooks. So everyone learns about fucking protons and neutrons and electrons, and they learn like their interpretation of what the main historical figures of society did. If you actually listen to what the main historical figures of society said about what they did, it's very different. People like Newton, right? Like if you look at like how they recorded him in history versus his own writings and words, it's very different. Clearly.
Yeah, up to and including removing the section of his Principia or whatever it's called, where he talks about his ether theory and gives like physical properties to it, and
right, exactly.
Has
minor details, Alan, just minor details.
Yeah, just minor details. Dude had a whole framework, bro, laid out. It was like, yeah, it must be 7,000 or what was it, 700,000 times more or less viscous than air or something like that. Yeah, viscous, whatever, viscous guy. Yeah, and all that. So he had a whole thing going on, and it was like, just no mention of that. Just stick to the apple falling on his head. Little did we know there was a whole situation and a lab frame that proves to be the ultimate frame, which is really just a frame of convenience to make the math easy, even though it's the only frame that matters, and all frames are compared to it and have to be equivalent to it. Well, covariantly, backwards compatibility works off of one frame specifically.
It only matters if you have to like make a measurement or build something in reality. Other than that, dude, it totally works and its covariant and C is always the same.
Oh yeah.
But if you have to measure it, well, no, we have to go back to C plus V because everything's in the lab frame. Actually, doesn't work that way. It always comes back to lab frame.
The old lab frame that'll get you.
I love in Bennett's presentation, he kept bringing it back to that too. He's like, yeah, so they did these measurements and they applied relativistic effects, and it was wrong, and it doesn't work, and it was wrong. Oh, it does work. Everything else without relativity.
Yeah.
We got to get Bennett on Discord down. You dropped the ball, bud.
It will. I'm doing it tomorrow. He said in the chat, I will contact you tomorrow. So
nice.
It'll be getting done. I'll call him tomorrow.
Do you guys remember Flat Earth Philosophy coming on? That was a nightmare. It was so hard to get him to like use stuff. We ended up going on Telegram to much fewer people, but it was he figured out Telegram but couldn't figure out Discord.
Yeah. Oh, that was when I remember that. Yeah, this will be way better.
I just heard a yawn. We better start closing the streams out.